Hey there, how's it going? Hope you're well. Today I want to take you through Linux troubleshooting of CPU and memory. Previous video I did was on networking, so today is CPU and memory, and I'm going to do another video in future on disk. And you need to know how to troubleshoot Linux really for day to day. You might have an issue, you need to go into the operating system and figure out what is going on, what is the root cause. Usually it's some rogue process or something. You need to find it, you need to look at the stats, and also you might even need it for the hiring process when you're looking for a new job. I have had troubleshooting scenario type interviews, and yeah, it's kind of like the new coding interview, but you actually have to fix a problem while you're at it. So today, CPU and memory. Let's get straight into this. One of the most basic commands you need to know is ps, and this is to check out processes. There's two ways to do this. So one of them is ps minus ef. Some people call this a standard syntax. And if you look here, it lists all the processes on the system, the UID, so the owner of that process, the PID, the parent PID. So every process gets a PID when it gets created, and 1 is the earliest, and as you go down this list, which is sorted by default, you see the most recent, the later processes, and you'll see here the command. I suppose it's the spawning command, or maybe there's a better way to describe that. So that's ps minus ef. Now there's no CPU or memory information, so let me clear the screen and show you there is a better way. There is a better command. Instead of minus ef, if you run ps aux, this is also known as BSD syntax, you get this instead. This is a lot better. Let me just scroll up, and it's kind of similar. There's no parent PID, but there's still a PID. It's percent CPU and memory use, which is much better. And then you have some other stuff here, and again you got the command. Now there are switches you can use to sort by CPU, memory, or any other column. And I'm not going to go into that because there's a better way I'll be showing you, but if you check out the man page, it's there. It could be useful to you for using in a script, for example, because it's not a very interactive command. There's no colors or anything. It's static, it doesn't change, so it would be good for scripting if there is something you wanted to take out of here. Let me give you a demonstration. I'm going to create a dummy process now. I'm going to run sleep for 1,000 seconds in case I forget to turn it off, and I'm going to send this to the background. And you see here it created process 2319 job number 1. So 2319. If I run a ps aux, then towards the end we should see it, and there it is, 2319 run by myself. And there you go, that's the command that was used to invoke it, I suppose. So 2319. Now what I want to show you now is, let's say this is a rogue process and we want to kill it. Then we make a note of the PID 2319 because we've looked it up here. Maybe it had a high CPU or memory. In this case it doesn't, but maybe that's how we found it. So 2319, we need to remember that. Let's kill this. Let me clear the screen. What we do is kill minus 9. PID is 2319 and it's gone. And if I run BG to see the background jobs, it says the job was terminated. This was it, and it was killed. So 2319, the sleep 1000 was terminated. If I run a ps aux again, you see there's no more 2319. It just jumps. So let's show you something here about kill. So I ran kill minus 9, and what that did was it ran a sig kill. So a kill signal is the most forceful way to terminate a process. Now I use it straight up, and I knew there was no risk of data loss or anything, so I just run kill 9 because I knew it was guaranteed to get rid of that. But if you run a production server or something and maybe you're worried about data loss or something like that, you might want to try other options first. So probably what you're going to use is sigterm. This is a graceful way to send a termination signal to a process. So you would do like 15 instead of 9, 2319, or whatever the PID is that you're using. Now actually, as it happens, the default for kill is actually to send a sigterm, to send this type 15 signal. So you can just get rid of that. So we could have just run this. There's no such process, but we could have just run kill and it would have sent a sigterm. And by the way, I want to tell you about this. Sigint is the equivalent of doing Control C. It's to send an interrupt request. That's like doing Control C, like this. But if you've got a problematic process, most likely you're going to have to send it a sigterm or a pkill. You're usually way beyond the point of being able to simply Control-C the process. Okay, it's probably not going to respond anyway. It's not going to play nice, I don't think, if it's rogue and consuming too much CPU and memory. So that's how to kill a process. Let me show you. We're going to come back to processes. Let me show you some other commands. Let's say you want to know what kind of CPU this is, and you would use the lscpu or list CPU command, and we'll come up with this. So I know that mine is 64 bits, so that's what x86_64 refers to. I mean, I think it can operate also 32, but this is essentially 64-bit architecture. And I've got two CPUs. Virtual CPUs as it happens, but to the operating system, on this level it won't necessarily know the difference. Two virtual CPUs of AMD. So again, this might be useful in using in a script as well. You might have a reason to check the architecture before you do something. That's I've done that before in my scripts. And there's some other info here, but not so useful. Feel free to have a look at that in your own time. Now, there's another command I want to show you. This is more related to memory, and this is free. Now, some people use free tac M, but I prefer H. They're similar. H is just the units are more human readable. So we've got these nice units here, and I've got 2 gigs of RAM on this particular server that I've got. That's why it says here total 2 gigs or 1.9. And I want to just tell you briefly what these mean, because it can be confusing for some people. So my total memory I've got on my server is really composed of, or made up from, 3 things. I've got programs using about 1/4 of a gig, so that's under used. Okay, and I've also got about 1/8 of a gig, 0.127 gig or 128 megabytes or whatever, used for buffers and cache. Okay, kind of reserved at the moment, used as a cache. So 1/4 of a gig is used by programs. About 1/8 of a gig, half of that is used for buffers and cache, and that leaves me remaining completely free, completely unused 1.7 gig. Now that makes sense. 2 gig, and then I've got used 1/4 of a gig, 1/8 of a gig. So I've still got roughly almost 1 3/4 gigs worth of memory completely unused, completely free, can be used for programs or anything else. This shed I'm not going to talk about because it's so tiny. I won't explain it. You can check that out for yourself on the man page. But what about this available figure? What is this? Now, usually what available means is available for programs to use. It normally means the sum of, quite typically, free, so unused, plus buffers and cache. Because the idea is, what is available to my programs? It's what's completely free and it's got nothing in it. It's just untouched. But also, this buffers and cache, although I'm using 1/8 of a gig right now, you can actually reclaim that, right? Let's say all of my free memory was used up, and it would appear I got nothing left, but actually we can empty the cache and say we're no longer going to use any cache. In an extreme situation, we can empty the cache and not use any cache and make this available to programs. So that's why available is typically free plus buffers and cache, and it may also be plus swap, but we don't have any. So, but typically available is free plus most of, if not all, buffers and cache. Now, you may have noticed, by the way, in my system this doesn't add up, right? So free is 1.7 gigs, buffers and cache is hardly anything, 1/8 of a gig, and it's saying here we got you know less. We got less than what's free. So there's something wrong with my system here. I don't know. I have a feeling it's to do with not much happening on this system. It's pretty idle at the moment, and I have a feeling that's why. If I was starting to use it, I think this would become more accurate. So in my case, it's wrong, but I want to tell you that typically available for programs is free plus buffers and cache. Just not in my particular case. Sorry about that, but there's nothing I can do about that. Right, let's move on. Let's get back to processes. I want to show you the command that most people use, and it's top. And you can see this is a lot more useful. Look, you see something move then? It refreshes. I think the default is every 2 seconds or maybe every second that it will update. And if you don't see any updates, it means nothing changed in that time. But this is way, way better. It's actually an interactive thing. Every time I can scroll down the list. So if you look, it's still sorted by PID over on the left. You see the PID there? It's sorted that way. I'm back at the top now. I can scroll down. I can scroll up. And as I scroll up, we'll also update. Now, this is a great command, but the reason I showed you PS is because it could be more useful in scripts, and also top command, I think it may not be available on some systems. Like you may go into a container and it may not be available, so you need to know PS because top might not be available. But pretty much top, for the most part, you're going to find it on 99% of Linux systems, I would say. So that's why a lot of people know top. There's even a command called htop, which is even more useful, but you won't find it everywhere. But top, you're almost guaranteed to find it. So let me talk about top. It looks a lot like ps-aux because it's got the PID, it's got the user, it's got CPU, memory, command. But it does do a lot more. So let me explain how to use it. First of all, let's look at the summary at the top. One of the things you get, let me put that back. One of the things you get up here is a load average, okay? And then you got some command, and you got some other stats here. Now, you've also got CPU and memory summary stats, and these are super useful. I'm going to explain some of these. So you've got here user space and system or kernel space, and as you can see, as a user and the kernel is hardly using anything. This is in percentage terms, right? Adds up to 100. Hardly using anything. Most of it, 99%, is idle. Okay, this is nice, which is not so useful. This is very useful. This means waiting for I/O. So if you've got a program that is blocking I/O, you're going to see it here. Now that's very low figure, 0.2. If you've got something that's like 50%, then you're going to know that this is, that there's a problematic process and it's blocking the I/O. So it's super useful to know. User time, system time, idle time, waiting for I/O time. Then you've got here very similar stats to what we saw in free. So you've got memory and swap. So 1 gig, free, used, buffers and cache. Just like what we were talking about. And look, you've even got that available figure there as well. Now, let's go down more to here. I want to show you how you can navigate around these columns. So the first thing that you've got to do is use X key on your keyboard and it will highlight a row. Now I'm pressing X back and forth and it's a little bit difficult to see at first, and you see it's highlighted this CPU column. So by default, when I press X, it's sorted the CPU column. But now I want to show you, I want you to remember this, PMT, and that's to sort by CPU, memory and time. And you need to do this with the shift key. You need to do uppercase PMT. P for CPU, M for memory, T for time. PMT. So let's do it. Hold down shift and press P, and you can see it's actually sorting by CPU. Now there's hardly anything running, so it's a little bit difficult to see, but if I scroll all the way so P, it means at the moment the highest CPU is at the top. If I press it again, it sends it all the way down to the bottom. It reverses, it actually reverses the order. PMT. If I do M, there you go. That's a bit better because memory is not as hectic, fluctuating up and down. It's more constant. There you go, M. So P for CPU. Actually, it didn't change the sort order, but anyway, P for CPU, M for memory. You see there, it's now sorted by memory, and T for time. Okay. Now, if you want to reverse the order, what you got to do is use uppercase R. So Shift R. So if I do Shift R, you can see we're looking at lowest memory usage. If I do Shift R again, we're looking at highest memory usage. So if I go back to, I do a Shift P for CPU, you got highest CPU usage. If I do a Shift R, it's sorted it to low. If I do a Shift R again, it's sorted by highest again. So if I go to time, so Shift T for uppercase T, and I now do R, uppercase R, so hold down Shift and press R, it's showing the earliest events. If I do it again, it's showing the latest events. So this is super useful for the time one, for seeing, yeah, earliest and latest, you know, what came before and what came after, that kind of thing. So I'm going to go back to memory because that's kind of the most useful at the moment. So Shift M for big M, uppercase M, and Shift R to resort. I'm going to leave it showing the highest memory usage. That's most useful at all. Now, another thing you can do as well, this may be easier for you to remember, is you can use the less than and greater than signs, which are on most keyboards. You hold down Shift and you press comma or period. So they're the two keys just after N and M on your keyboard. So less than and, to get less than and greater than, you've got to hold down Shift, right? So if I hold down Shift and press the key that's got less than or the key that's got greater than, then if you look, you can see that I'm going from CPU to memory to time. You see that column highlighted, a little bit difficult to see, and I can go all the way over through all these other stats, all the way over. See, I'm on user now, all the way to PID, and if I now do Shift R for uppercase R, I can sort by PID and reverse sort by PID. So this may be more useful for you to know. Just use this kind of like left and right arrow style with less than and greater than, and then just use when you need to. So let me get all the way back over to memory, then just use Shift R and sort. But personally, I like to memorize P, M, and T. I find them super useful. Another thing you can do is uppercase V for the forest view. Look at the command, watch this. You can see what spawns out of the other, the parent command or parent process, and you can toggle. So again, this is uppercase V, so Shift V on the keyboard. You can toggle between the two. Now there's way more commands than this. I just wanted to show you the most basic ones. You will in a let's say an interview scenario or in a real life troubleshooting scenario, you cannot count on other commands being available. I would say that you do definitely need to know how to sort by CPU and memory and other columns as well. Because what you can't do is you can't just go like this. Remember, if I quit out of this, I'm going to press Q and clear the screen. If I run this again, by default it's in PID order. You see over here? Now if you're looking for a rogue process, sorry, actually by default it may be CPU order, I think. If I press X, there you go, highlight the currently sorted column, which is CPU. Now, it's all well and good if the process is using the maximum CPU all the time. You're trying to hunt this down, it's going to appear at the top. But if it's fluctuating, or if it's not using the maximum CPU, or if it's using memory in high amounts, if you just scroll down up and down arrows, which is what I'm doing now, that's why you're seeing this move. If I just do that, you might not find this process. It could be jumping all over the place. You know, you need to know how to sort by columns. It's the only way you're going to find one of these processes. So, press Q to quit again, or you can use Control C to pop out of this. That is top. Super useful command that you need to know how to use. Now let me show you another great command, and it's another alternative. And this is one that you might install on maybe your, I don't know, a server that you have to commonly go into, or your own laptop or something, and that's htop. And as you can see, it's very similar to top, but it's a lot more interactive, a lot more friendly to use, and the memory and CPU stats are kind of presented differently. You've got this kind of like a meter for memory, so you can see that's why I'm hardly using anything. It's only about 20% filled, if that, and it's showing. And again, you can go up and down, but it's a lot more user friendly. You've got this green bar, and you've got F commands to do all kinds of different things, search for processes, sort by. So there's a lot, even to kill directly from here you can kill. So yeah, this is a lot more interactive and nicer to use. Although, would you install it on a server? Yeah, I'm not sure. Some people would say yes, go ahead, put it on all our servers, and other people would say no, don't want to do that. Leave top, but don't install htop. It's a bit too much. You're starting to make it like a desktop system potentially, so, you know, and it's consuming valuable amount of memory, right? I mean, if we look at this htop, then well, it's not using much in the way of CPU, and yeah, even memory, it's only using 0.2%. I mean, that's hardly anything. But I've not seen htop installed on many servers, right? But top you'll find, I think, possibly in the default Ubuntu install. So let me quit out of this. I'm just going to Control C out of this. That was top. Sorry, that was htop. A lot nicer to use. Now, let me show you, I think, one more command pretty much, and that is vmstat. So if I run this, now vmstat, it kind of sounds like virtual memory statistics, but to be honest, it's what it's showing you is it's showing memory, but it's also showing you additionally swap in, swap out, and it's also showing you I/O, so blocks in, blocks out. It's showing some other things, I forget what these stand for. It's also showing this, remember this, user time, system time, idle, waiting, etc. So this shows it in a different way, but the great thing about vmstat is that you can tell it to do it over time. So I'm going to say, so what you do is if you just do vmstat, you can say vmstat 1 to 10 seconds, and it will do every second. It will get those stats, and it will do it for 10 seconds. So pretty cool. So you can see actually when I started to run this command vmstat, it actually caused a lot of a small amount of blocks in, and a few blocks out, but they quickly decayed. It went to 0. And you've also got here some other information as well, so you can see the user times, you know, that rapidly went to 0, system time went to 0, etc. And nothing much was changing over time here. What you can also do, instead of vmstat 110, you can just say vmstat 1, and it will just do a continuous vmstat. So yeah, again, very useful. And you can change this as well to say vmstat 2, and it will only run it every 2 seconds. Maybe you don't need the fine granularity of every 1 second, then you can change it. Now, what it won't do for you is it won't aggregate any stats. As you can see, it's just giving you point in time stats. But this is super useful because if things are fluctuating a lot, it's going to be very hard to notice that in top. It's just going to look like a mess. And this is great for seeing fluctuations. So yeah, vmstat is a super useful, super cool program. Now, let me show you, finally, I'm going to run a script that I've got to sort of stress test. So I created this thing, and this will create some CPU use, some memory use, and also some disk activity. And I just used ChatGPT to create this. It's nothing special really. So it's doing a stress test. Actually, I'm going to Control C. What I'm going to do better is to send that to the background so that I can use these other utilities, these other tools. So it is actually in the background. If I go background, then it's actually it's there. So let's run top, and what you can see here is actually spawned a bunch of DD commands, and this is for the disk activity. Let's sort this. So let's go X, and if I scroll, there you go, CPU, and then I do Shift R to sort by CPU, then yeah, you can see all these DD commands are consuming quite a lot of CPU. Now I know this adds up to more than 100 because I think these are actually they're not all running at the same time. I think some of these are old and not running, or maybe they're, I don't know, there's some weird thing going on, but they're not all running at the same time, that's for sure. If you look up here, we can look at the load average. It's still fairly low, and if we look at the CPU, we can see that 22% is user time, 78 is system time. It's not idling at all anymore, but the wait time is 0, so that's good. Honestly, this hasn't changed. Oh, it has changed actually considerably. So we now got about a gig that's used, and yeah, really not so much free. And this is interesting, there's a lot buffered and cached. Not sure why that is. Maybe one of you can explain that. But anyway, I wanted to show you that. Let me also show you, we'll go back to the vmstat, and let's just run that continuously. And you may notice some differences here. I think, in fact, this cache looks a lot bigger than before. By the way, this R I think means running, so I think they are actually running at the same time. We've got 5 DD processes, and obviously the user time and system time are different because we mentioned that before. You can see that there's roughly 20% user time and 80% system time. You can see the header gets replayed when the screen gets full, so that's kind of useful. And the other thing I really wanted to point out to you was blocks out. Because we're using this DD command, you can see the blocks out are really high, and almost continually there are blocks out. So yeah, this is indicating some disk I/O because the command is using DD. So yeah, there we go. I'm just going to kill that now. Now there is another command I wanted to show you finally, and you can actually use pkill. And F doesn't mean file, but it is commonly used when referring to if you want to put a file name in for a script that's causing it. So pkill -F, and there you go. It terminated that. And if I go background, there's nothing left. So I hope you enjoyed this video and you know a lot more now about troubleshooting CPU and memory. I will show you the next video on this series is going to be about disk I/O, so look out for that. It's going to be super useful. Hope you enjoyed it. Give it a thumbs up, subscribe, and I'll see you again soon. Take care. Bye-bye.